Hi class, so I want to record another video explaining some of the limitations of running stepper motors. They're just different than permanent magnet DC motors, and I need you to understand the kind of the differences in how they operate and some limitations. So first off, what you notice, I added an LED here to pin 13 with the resistor to ground. So we're going to use that to indicate a couple things. I'm going to minimize this a little bit first, and then we'll talk about some code that I'm going to run, and we'll talk about it. So first off, we're going to put in idle mode code. So similar code, I have the stepper motor library. I added this LED pin to pin 13, and nothing's in the loop function. The only thing that's going to happen is the in the setup function. And what we're going to do is first thing is set the LED as an output, and then set it to be a high. Okay, this will turn the LED on. Then I'm going to set the digital pins 2 through 5 for the stepper motor as outputs. And then I'm going to turn pins 2 and 4 on as the step 1 in the sequence of the stepper motor. And then I'm just going to sit and wait for 5 seconds. And after 5 seconds, I'm going to turn the LED off, and then I'm going to turn all the pins off to the stepper motor. Okay, so turn the LED on, turn the stepper on to step 1, wait 5 seconds, and then turn everything off. So I'm going to go back here to full screen mode so we can watch what happens when I do that. So I've already programmed the stepper motor, so all I have to do is hit the reset button, and you'll see again the LED will turn on, and then we'll give it one step for 5 seconds, then everything will turn off. Notice this spins really freely right now. And then once I hit the reset button, LED turns on. Now there's some slop in this wood piece, but it was hard to turn, and then now it's easy to turn again. Okay, so the difference in torques between now and when the stepper was on was 2 different types of torques. So the torque right now, when the stepper is off, is called the detent torque to get this to turn. It's easier to feel than it is to hear, but there's just a little bit of kind of stepping resistance as I rotate this stepper motor. Okay, that's the detent torque. So you have to make sure whatever you do is at least strong enough. You have to give enough power to overcome that. And when I power this, then it really is hard to turn, and that's called the holding torque. That's the maximum torque the stepper motor can provide. So when you purchase a stepper, you have to make sure that whatever torque you need to turn is less than the holding torque of the motor. Otherwise, the motor's just not going to be strong enough to turn. So I'll demonstrate that again. So I'm going to hit the reset button. So it's on, so it's really hard to turn. I'm pushing hard, and as soon as the light turns off, now it's easy to turn again. Okay. So that's the holding torque is the strongest, that's the max torque, and then the detent torque is the minimum torque. That's just to get this to spin freely. Now there's one other thing I wanted you to notice from this. I'm only commanding step 1 in that sequence. In the previous video, we commanded steps 1 through 4, and that's what made the motor spin. If I just turn it on to one step, notice, and I don't want my motor controller getting too hot here, but with just one step, it doesn't rotate. I mean, it's locked in position, but it doesn't spin. So permanent magnet DC motor, you can just give it power and it just spins. But a stepper motor, you can't just give it power. You have to switch the power between the steps in order to get it to rotate. So powering a stepper motor locks it in place. Stepping a stepper motor makes it rotate. And sometimes you want both. You want to turn and then lock something there, and other times you want it to spin. So note that difference. Okay. Next, what I want to do is demonstrate, I'm going to minimize this again, and we're going to demonstrate another code here, number 5. And let's minimize number 4, get that out of the way. We're done with that guy. So this number 5, what we're going to do is talk about some delay issues. Now what this code does is turn the LED on, and I want to rotate 10 times. So using the stepper library in the setup, I'm going to set the speed to 240, turn the LED, well, make it an output and then make it off. And then I'm in the loop function. This is kind of like the blink function, where I'm just going to turn the LED on and then turn it off throughout the loop. However, between turning the LED on and off, I'm going to rotate the stepper motor 10 times. So I'm going to send 10 times 200, so 2,000 steps to the stepper motor. And what I want you to notice is how long it takes to do this. Notice there's no delays in this code at all. There is nothing slowing this code down. There's no delays. The only thing that's going to delay the lights is the stepper motor itself. So if we go full screen here, oh, I forgot to upload it. It's powered up. So I'm just going to upload it and it'll start spinning. I'm going to go to full screen here. Okay, now notice the light, there was no delays. In the blink function, when you first learned to program an Arduino, if you took out the delays, that light would flash so fast you wouldn't be able to see it turning on and off. But now it takes a long time between on and off flashes because it's taking so long to turn 10 rotations. And what I want you to see from this is that notice how long it takes to do this command. If it turns the light on, it can't turn the light off until it's finished running this command. And because I'm telling it to rotate 10 times, it's going to take a long time to finish that bit of code before it can move on and turn the light off. So a lot of problems I see with programming stepper motors is we try to, I'm going to turn this off now. We try to command the stepper to move a large amount of steps, but then the Arduino can't do anything else because it's just sitting there thinking about moving its steps. It's ignoring everything else that's happening. So if you're going to rotate a large number of steps, it's ignoring sensor inputs. It's ignoring, let's say you had an e-stop and you're trying to press a button to tell it to stop something. It will ignore it until it's completely done moving all of those steps. So what you want to do to avoid this problem of waiting forever to run these steps is just run a couple steps at a time and then loop through again. So this is what code number 6 is doing. So code 6, the idea is I'm going to run one step at a time. And then in my function, direction is just a positive or negative number. So 1 means clockwise, -1 is counterclockwise. And then if I move just one step at a time, then it's really fast, and then I can move on and do other things with my code. So what this code is going to demonstrate is I'm going to blink the LED on and off 200 milliseconds in between blinks. Okay? And then it should blink at the same time the stepper motor is running. In this code right now, notice that the light is either blinking or the stepper motor is running, but not both, right? Well, in this new code, what we're going to do is we're going to show that you can actually do both. I'm sorry, I'm just covering up this light. It's kind of bright. But, and how we do that is we just check the time. If I want to blink every 200 milliseconds, then I'm only going to step one step at a time, add to my step count how far I've moved, and then just ask, is it time to reverse directions? If so, then wait a second. Reverse directions and wait a second. That's the only delay in the whole thing. In fact, I don't even know if I need that, really. It's just hard to tell when it reverses directions if you don't pause. If it's not time to reverse directions, and if it's not time to change the blink, then the code is running really fast. It's just doing nothing but stepping one step and then counting the step number. If, however, the current time since the Arduino has been on, minus the last time it was blinked, is greater than 200 milliseconds, then I want to reverse the state of the LED. So if it was high before, then I'm going to reverse it. That's what this says, not. It just reverses from high to low or low to high. And so I'll turn it either on or off. So this way I can control how often it blinks, while running the stepper motor. And in a way, what this does is it makes it look like two things are happening at the same time. So I'm going to plug this in. Let's upload this code, and then let's show this. So notice the stepper motor is rotating, the light is blinking, all at the same time. The only time this light stops is when this motor stops. And the only reason it stops is because when I tell it to reverse direction, I have a delay where I tell the Arduino to just go dumb and do nothing for a full second. So that's why it stops, the light stops for a full second. And let's try taking it out, see what happens. So I'm going to blink the LED even faster. Let's go 100 milliseconds in between. Let's upload that. So now you can see, now it's even blinking even faster. I took out the delay, so the LED never stops blinking. The motor just reverses direction quickly. So it looks like two things are happening at once. And that way I'm not waiting forever for this stepper motor to turn before I change the blink of the LED. So I'm going to turn that off. And again, just want to demonstrate a couple principles here. So for what we learned in this video is one, stepper motors, you have to step through the sequence in order to get it to rotate. It has a holding torque and a detent torque. And then if you give it a large command of steps to do all at once, it just takes too long. So instead, it's recommended to have a really fast loop where you just step a little bit at a time and you just cycle through that loop really fast. And you only interrupt it for a brief moment if you have to do something like tell it to change direction or tell it to blink a light. Okay? Thank you.